As always, for these concept check videos, I'll encourage you to pause the video on each question or each new slide and work through the questions yourself. Then unpause your video and we'll walk through the answers together. And if at any time you find that your answer is incorrect, I'd recommend that you stop the video and take another stab at the question before watching the correct solution. So go ahead and pause your video now and draw the structure of 2,2-dimethyl 4-propyl octane. Okay, to convert a name to a structure, I like to start with the parent, which tells us how long the main carbon chain is. Here the parent is octane, so we draw a chain of 8 carbons. Then we need to tackle the prefixes that tell us about the substituents, and we want to do this one at a time. I'll start with the 2,2-dimethyl prefix, which tells us that we have 2 methyl groups at the 2 carbon. Then our second prefix, 4-propyl, tells us that we have a propyl group at carbon 4. Remember that a propyl group is a chain of 3 carbons. So we add that to position 4, and our structure is complete. We'll just redraw here at the bottom for clarity. This question is asking you to name the structure drawn. So now going in the other direction, we want to first identify the parent. And the parent needs to be the longest chain that contains the most substituents. So here the parent is hexane. And then we number the chain starting at the end with the most substituents closest to the end. Then we name our substituents. We have 2 methyl groups at carbon 2. So we need the prefix 2,2-dimethyl. And we have 1 methyl group at carbon 5. So we have a 5-methyl group, or a 5-methyl prefix. Because all the substituents are methyl groups, we bundle them together and indicate that there are 3 by using the nomenclature trimethyl. So this molecule is named 2,2,5-trimethylhexane. This question is asking you to draw 5 different constitutional isomers of C6H14 and to name them. To do that, you need to remember that constitutional isomers are structures with the same formula, here C6H14, but with different connectivity of the atoms. You should also realize that C6H14 follows the standard formula for an alkane, so we have no degrees of unsaturation here, no alkenes or alkynes, and we're just dealing with the linear and branched forms of an alkane. For me, the easiest way to draw these is to start with the linear hexane. Then for my second structure, I'll introduce 1 methyl group and I'll position it at the 2nd carbon. For the third structure, I'll just move that methyl group over 1 position. And now if I move it over 1 more, I have the same structure I just drew. So to draw another constitutional isomer, I need to introduce additional branching. So now I'll try 2 methyl groups. And first I'll put them on different carbons, and then next I'll put them on the same carbon. I like to be systematic about these so that I can make sure I identify all of the isomers. Okay, now naming the alkanes, the first one, the straight chain, is linear hexane. The second has a methyl group in the 2 position, and the parent is a 5-carbon chain. So this is 2-methylpentane. The third has a methyl group in the 3 position, and is 3-methylpentane. Our fourth isomer has a methyl group on carbon 2 and on carbon 3, and a parent chain of 4 carbons. So this is 2,3-dimethylbutane. And finally, the last structure has 2 methyl groups on carbon 2 and is named 2,2-dimethylbutane.